Okay, the first thing I want to talk about this week are anonymous functions. They're also called lambda functions from when they were originally invented for the language Lisp, where they used lambda. In fact, this comes back to sort of original logic of the 1920s. They used lambda as the stand-in for a general function. But they are a common feature of a lot of programming languages. Scala is no exception there. And the goal is that typically when we write functions, right, we give them names and we have, say, like this definition format, which we say multiply by 2 of x. It takes in an int, spits out an int, and what does it do? Whatever is in those curly braces. But for a lot of times, especially we'll see with functors, we are often passing in very simple things like multiply by 2. I don't want to have to always give names to all of my functions. So sometimes I want to just be able to write up a function as its definition without actually having to name it at all. And that's what an anonymous function is, right? Anonymous because we haven't given it a name. So let's look at how we write anonymous functions in Scala. Let's say multiply by 2. This is our normal type of function. And the typical format for a anonymous function is in parentheses is the parameters, and then a equals greater than arrow, and then what we want to do to that input. So this is a typical anonymous function. I can give it a name. So instead of this function definition like above, I can give it just a val name, right? So let's do anon mult is equal to this guy. And so you can see it's slightly different, right? Up here I said multiply by 2, this is its name, this is the parameters it's taking in, then equals a block of code. Here I've given anon mult is just a value name, and it's equal to all of the stuff on the right-hand side, which is the anonymous function. So the standard is in parentheses are what are the parameters of the function, arrow, and then whatever we want to do with those parameters. Another way we can specify this is actually even simpler, which is something that looks like this. So I'm going to give the type annotations here, right? Anon mult, I want it to take in an int and return an int. And what is this going to be? Well, it's just going to take underscore times 2. Right, that seems a little weird maybe, but it works. And let's test that out, right? Anon mult on 5 gives me 10. And so what's the difference between this anon mult and this one? Well, this one I've given a name to my parameter, and then I use that. Here, the underscore is a stand-in for the parameter. We already saw the underscore as a wildcard in case pattern matching, but here it actually matches the parameters of the function. This is one reason why I gave the type definition here that says it takes in one int and returns one int. That way Scala knows that this underscore is whatever that int is that's coming in, and then I can use that. So the underscore is very powerful, but can be a little deceiving if you're not paying attention to what's going on there. For instance, we can use the underscore with 2 numbers, where the first underscore will correspond to the first parameter, the second underscore will correspond to the second parameter. So for instance, let's do add 2 numbers. This is going to be a value of type int to int, right? So it takes a tuple, a pair of ints, and returns a single int. And it's just going to be underscore plus underscore. And surprisingly, that works. So you can see that, especially when we get into, say, using maps and functors, you can just pop in underscore plus underscore into a place that requires a function, and it will return the anonymous function that just adds those 2 inputs. Really useful.